Welcome back. This is part 2 of our e-bike build. This bike started as a 1970s women's Schwinn, and here's where we're at. So great, now you're all caught up, and if you want more details on how we got to this point, you gotta go back and see part 1. But since part 1, we built this light-up battery box for housing our batteries and our controller for the electric motor, as well as went through and added in gussets for just bracing. Continuing with this build, we have to somehow transfer power from the motor to this rear wheel. Typically that's done with a sprocket because it's mounted to the center, but we don't actually have a sprocket or a central hub. So what we're doing is a friction drive system, and I had originally designed this with one wheel and then modified it to 2 wheels that hung off the motor. I didn't really like that, but so I lost all the footage because it was so convoluted. But this is where we're at. Basically it's 2 shafts with sprockets on the end mounted to skateboard wheels actually, and then these all just free spin. So we're ready to put this in now. When you drive a sprocket, it'll go clockwise or over the top forward, but since we're driving off the inside or the outside of the wheel, we actually have to spin it in reverse. So in theory, we're pulling off the bottom side, spinning counterclockwise, and my hope is that since the chain will go from here down, it's going to want to pull this and then pull this into the tire. The more torque that is delivered, the harder it'll push in the tire, giving us better traction. That's the idea, at least. So our motor came in, and we can start figuring out our motor mount. I think we're going to go something like there, and put in the motor to figure out spacing, and then we'll just try to line these up, drill out our holes, and then weld our plate down. Yep, that looks good. Line it up, something there. We got the motor mounted to our plate here, and yeah, there we go. And then we should be able to line it up off of the face here. Make sure it's all flat. And then we'll come through here and weld the bottom plate in. So to add tension on these rear drive wheels here, we came up with this system, which is a piece of all thread, and it's welded to this crossbar, and then has a spring that pushes tension down here, and then this just has a little mounting plate underneath the motor here, so that shares mounting screws, I guess. But then we can adjust the tension on this by threading this down, which would then push that into the wheel more. So while we're waiting on our chain to come in so we can hook that up, we can just temporarily hook up the rest of the electronics so we can test it out when the chain gets here. So our battery pack will sit in here, something like that. And then we'll just use some zip ties to hold it all in place for the time being. This isn't how we're going to hold it down routed like this. I just don't want it to fall over while we're testing it out. Now let's hook up our motor here first. So we are spinning this in reverse, so we had to switch. I think it was the yellow stayed the same. We had to run blue to green and green to blue. And there are instructions on wiring these to spin backwards. So in addition to plugging these, the blue to the green and the green to the blue in here, you also have to switch the blue and the yellow in this line, which we had done already. All right, let's turn it on. Works. So our new chain came in, and we just have to break it down into length. So just using a chain breaker to pop these links apart. We still have to build an idler that puts tension on here, because this just puts tension going that way. Really, the more tension we put on that wheel, the more it'll stretch this out as well. But I think at this point we can test it and see if it'll actually kind of do what we think it'll do. Hope it'll do. All right. Well, if that's not a proof of concept test, I don't know what is. So, working from my bucket of bearings and bag of miscellaneous springs here, this is what we came up with for our tensioning system. It's a piece of nylon that we turned down to fit the profile of the chain, with 2 bearings on the inside, and then a spring running back to here. It holds tension on it. And then we just have like a bronze light bushing that's in there to let this pivot. I think it seems robust enough to let's put it on the ground and see if it'll move us. Oh geez, this thing has gotten progressively heavier. We'll have to throw it on a scale just to see how much it weighs, but throw in your guesses now. I'm going with 110, 115, but let's see if we can. Right now the wheels are just spinning on the rear drive rollers, so I think we need to add some more tension to those guys. It did move, it's just needs more tension. And it could be because the tires are low too, which affects how much tension these get. So let's put some air in the tires and see if we can fix that. So because the valve stem is recessed in there, We can't actually get a tire chuck on there, so we're just gonna blow air in and just give it all of it. Might not be the best solution, but it is the solution that we came up with to fix that tire issue. And then let's give it a couple of rotations down here to add some more tension on it. Alright, we haven't fixed the spinning issue yet, but let's see how well it goes. It definitely goes. It's a lot faster than I thought it would be on the low end. It did occur to me that we forgot something, and that's where I'm gonna put my feet. So we'll have to come up with something for that too. Either we'll go up front here or in the back. I'm not sure yet. We'll figure that out. Probably the most important question is, can it do a burnout? This 1970s women's Schwinn has ever spun these tires like that. That's awesome. So we started disassembling it. I do have some more finish welding I have to do, get in here and clean it all up, but at this point we're going to just continue disassembling this, and it's probably not going to be that interesting, so what we'll probably do is just cut to when all the parts are cleaned and painted, and then we'll start putting it together. So I think we're going to start with the transmission sub-assembly first, just because it's got the most tiny little pieces, so let's jump into that first. Alright, so we need our spacers. At this point, we can start putting our wheels back together now. Right, now we want them all in. Alright, one wheel put back together, and we did get some new rubber for this guy. And a new inner tube. So one thing I did learn that when searching up new tires is that not all 26-inch tires have the same rim size, and I guess these early 70s, late 60s Schwinns used a really large size wheel. So just something to keep in mind if you're working on an old Schwinn. They don't take standard new 26-inch tires. So let's put some air in this guy. I don't know about you guys, but I haven't bought bicycle tires in a long long time. That being said, apparently bike tires now come folded up. I was waiting for the box to get dropped off of, you know, a decently sized box, and everything comes ziplocked in like a little baggie now. I guess I got the right size wheel. So definitely going on a lot more difficult than it almost came on. Alright, one wheel down, one more to go. So, we've got the wheels put back together. I think we can start building the carriers for each set of wheels then. We can put our wheel on. So next I think we're going to start assembling the center section of the frame here. And we cleaned up all the old original bearings. So figure these things are like 60 years old, and yeah, they're good enough. It's not like we're going for any like high-speed racing records or anything like that, but just in case, we are gonna re-grease them with Lucas high temp grease, because that's what I have. Yep, seems fine. No, that's enough. No, it doesn't like that. Remember back to the first video, we did have to torch this all apart, so it got a little cooked, but it still fits. Have to come back through and torque that down, but we'll just pretend it's good for now. Alright, so we also want to put our steering arm assembly together. And this goes in there like this. So we are using a nylon lock nut on here, but I don't really trust my teeth to this not unthreading and having the front wheel fall off and me going over it. So we're gonna drill and pin this, and I already drilled out the other side and then the screws. And then just using a cotter pin, we'll slide that through it, and that'll keep it from backing off on us. All right, what do you guys want to put on next? The transmission? Great, that's what I already pulled out and all the hardware to put it on. Alright, so I think we're ready to put the motor in now. Drag that through there. Slide our spring on. We're ready to mount the battery, and I did put little pieces of non-skid in there, but I wanted a bit more protection on the side from it rubbing on metal, and so I cut up this section of conveyor belt that I have, which is fiber reinforced rubber, and see, that's why you just can't throw stuff out, because someday you'll need it. I must have had that section of conveyor belt for at least a dozen years. And then we'll do the same on the back here with our other bracket. Alright, so keen observers might notice these studs sticking up, and these are just bolts welded to the tops of these plates, and that provides a mounting spot for that guy. Putting our steering together, I don't remember exactly offhand how far these all thread in, thread out, so it will be, they are adjustable, so be some trial and error, I suppose. Alright, I think we're ready to put the seat on, and you might notice we did a little mod to the back here. We ended up lining the inside with LEDs, so not only will this glow blue, but now this should glow blue as well. So you might be wondering what the torque spec is for these, and it's all of it, plus a little bit more. Yeah, it was too much. not that much. So our foot pegs came in. These are just aluminum, the cheapest you can find on eBay. I think they were like 15 bucks or something, but they look the part. We made these brackets out of aluminum, and I mean, they have a bit more flex than I really want, but they're all bolted on, so if we need to make them out of plate steel or something, we can always beef them up, but for now, it's good. So we'd finished all the wiring and have everything wrapped and segregated the lines into which runs through which. So up here we have our 48 to 12 volt converter, and then we have our controller, and then over here is our battery, obviously, and then all the wiring is just kind of tidied up. So at this point we're ready to hook our LED strips, which we have these connections down here, and those will get snapped into here, and then the whole housing can go on. So this part is kind of a juggling act, trying to get these held together and clipped in. We never checked to see if this fits even. I ended up having to take our seat back off. We managed to get the battery box back in. With all these wires back here, it ended up getting to be a pretty tight fit. So let's see what the lights look like. Turn the mic on, and then the switch for the lights is back here. So it'll blow it out here, and then the back here. So that glows back there. Let's kill the lights and see what it looks like. Right now we're just finishing up on the brakes here. We ended up going with the original Schwinn clamping brakes. And the motor controller does have regenerative braking. We would just have to change over the handlebar grip. That one has a sensor in it that runs down to that. They're pretty cheap, I think like $5 or so, but I like the look of the aluminum one, and we have it on hand, so that's what we're using now. Clamps and releases. And we'll just trim this wire back. And sure. Alright, I think I'll probably just go over the nuts and bolts, make sure I tightened everything down, but I think we're done. So when we originally set out to build this project, I had set up a budget of roughly about $400, and normally I don't tally up a list because you know, I know how these projects go, but let's just go through the cost and kind of give you an idea of what it took to get to this point. So let's start with the bike. The bike was, well, what started this whole project, and that was by far the cheapest part. So the bike started out at $10. Then the steel tubing, $160, the motor kit, $130, battery, $200, paint primer clear coat, $84, tires, $45, voltage regulator, $17, foot pegs, $15, brake cable and pads, $15, chain and sprocket, $30, rivets, $8, LEDs and switches, $20, skateboard wheels, $16, bearings, $20, nylon bars, $35, riv nuts, $10, welding gas, 2 tanks at $85, hardware, $75, for a total of $975. But I also live in the land of Lincoln, so we get to pay 2% tax. So that's another $86, bringing our total to $1,061. And that doesn't include a lot of the consumables like cutoff wheels. It definitely doesn't include the electricity, because as soon as you crack that arc on the welder, you can just watch your meter just start spinning. And a lot of the other small ends, electrical pieces and stuff, it's not included in there either. Also not included is about 400 hours of time to actually engineer, design, and actually build this whole thing. So yeah, it just kind of gives you an idea of what it costs to get here. So yeah, building something like this is not cheap, I guess. For the same price, could you go out and buy an e-bike? Sure. So with that being said, make sure you like and subscribe. That really helps us out in building more of this kind of stuff. But we already know that it'll do super smoky burnouts. Let's take it out on the road and actually see how well it does. So this build was never intended to be daily driven. The seating position is extremely uncomfortable, and the wheels, although they look cool, they're not really that efficient. There's a lot more frictional drag in this kind of setup than like a traditional hub and spoke system. Back in the 60s and 70s, guys like Roth, Barris, and Von Dutch were designing really cool-looking movie cars, and although they were functional, those also weren't intended to be daily driven. They're just mainly designed to look cool on screen. So I think it's only fitting that when we went with a similar design and direction, that you know, we also start with a Schwinn that was made in the 60s, 70s. My goal with this build was to also build something that looks cool, but is also functional. I'm pretty happy with the way that it turned out, the way that it looks, the way that it functions. I hope you guys enjoyed this project too. So until next time, thanks and take care.